Hi smart learners, today we'll be discussing simple approach to balancing chemical equation. Now presume you are given this equation. What do you have to do? Draw a table like this and write out the atoms on the left hand side and the same atom on the right hand side of the equation. So you look at it. So hydrogen here is 1, hydrogen here is 1. So you add it up, that gives you 2 on the left hand side. Hydrogen here is 2. Now nitrogen here is 1. There is no nitrogen atom here. So nitrogen on the left hand side is 1. Nitrogen on the right hand side is 1. Oxygen here is 3 plus 1 here. That is 4 on the left hand side. Oxygen here is 3 plus 1. That's 4 on the right hand side. Then sodium here is 1 on the left hand side. Sodium here is 1 on the right hand side. So when you inspect this table, you see that the number of atoms on the left hand side of the equation equals the number of atoms on the right hand side of the equation. And finally, what do you have to do? You now add your what? Your state of matter. How do you add your state of matter? Of course, you know this is an acid. You put aqueous. This is also an alkaline. You put aqueous. This is also a salt, a soluble salt. You put aqueous. And this is what? Liquid. You put up. That balances the equation. Now, presume we are given another example. Presume we are given another example, which is we now have here to be potassium tetraoxomanganate 7 plus hydrochloric acid, giving you potassium chloride plus manganese 2 chloride plus water plus chlorine gas. Now, how do you balance this equation? This is where this approach comes in. Now, when you have an equation like this is a very complex equation. Therefore, you cannot use the conventional or the universal method of balancing chemical equation to balance this. So how do we go about this? This is a very simple way. So all you just need to do is to put here to be A, B, C, D, E, and what? F. So instead of putting a number here, you put letters, alphabetical letters here. Now, in this kind of equation, whenever you see, how do you know when to use this method? When you see an equation that has 3 reactants or 3 or more products, of course, you use this equation, as conventional method will be ineffective. So very simple. We start. Potassium, A times 1. That will give you A equal to, there is no potassium here, we have it here, A equal to C. For manganese, A times 1, that will give you A equal to what? Equal to D. And then for oxygen, A times 4, that will give you 4A equal to E. And then for hydrogen, B here equal to what? 2